Good morning, grade 9s. I trust you had a wonderful holiday and you are refreshed and ready for term 2. I will be your online teacher for this term to cover the next few sections. So let's hope we have a productive learning experience online. Special greetings to 9A. Hello 9A. I am actually missing you. I hope you are well and behaving. Now, I'm going to do things slightly different from the way Mrs. Smith did it. So this is how it's going to work. Firstly, I will put up an online work schedule on Google Classroom where every day's work will be reflected in this schedule. So please can I ask you to go through it. I will update it regularly. I will outline what exercises you need to do, what videos you need to watch, etc. So if you are lost, please refer to that and it will give you an idea as to what's going on for the next few weeks. You have a timetable that is probably sent to you by now, an online timetable where there are certain allocations for mathematics. So maths will take place 4 days in the week. I think Thursday is the no maths day. During that hour, you will watch my videos and do the work that I have set for you. I will make myself available live for the last 30 minutes of each session. I will talk about that more later on, and I will let you know how you could get onto Google Classrooms where you will find the link to Google Meet, and then you can ask me whatever questions you have for that particular lesson live if you wish. If you don't want to do that, you're welcome to email your question to me and I will reply to your question. Send a photo of a problem, send a photo of your solution, whatever is bugging you, and I will help you with that question. Or you could email me privately and I will do a private ASP with you online. Please look out for messages that I put on the stream to update you, or if there's a slight change or an amendment or whatever it is, just please frequently read those messages. You will get an online quiz after equations. So the sections we will cover are, firstly, this week would be based on revision of factorization and fractions, and then we're moving on to equations. After equations, I will do an online quiz before we move on to the geometry afterwards. Well, depending on what's going on, we'll take it week by week. I do expect you to do the work as homework. If for some reason you are unable to finish it in the allocated slot on the timetable, then as we normally do in class, whatever's not done in class is regarded as homework. So you would have to find time after the school day and do the homework before the next maths lesson. I will put up the worked solutions where I show all the working out for all the exercises that I give to you, whether it's from the textbook or whether it's on a worksheet. So please, it's your responsibility to do the work. That's the only way you would know if you actually understand the sections. When it comes to notes, and I know a lot of you like to write notes, whatever I teach you and all the examples I work through and record, I will put a PDF copy for you so you can either copy it down or you can get your parents to print it and you can stick it into your books. It's up to you. So don't stress about taking down notes while I'm teaching. I will put them up for you. Okay, so let's begin. Revision of factorizations. If you recall, last term you did factorization and the sections covered there, or the topics covered, was a common factor, the change of sign rule, difference of two squares, and trinomials. And as I've always said to my class, the golden rule for factorization is to always look for a common factor first before you start. So I'm going to quickly go through different types of questions. Some of you might know this, but there's no harm in looking at it again and revising your work because factorization comes up in everything. So let's go through example 1. Factorize the following expression: 4x squared minus 12xy. Remember, golden rule is to look for a common factor. So if you look here and if you remember, when you're looking for a common factor, it can be a number, it can be a variable, it can be a number and a variable. Okay, so we've got, let's look at the numbers, 4 and 12. between 4 and 12, the highest common number is 4. So that will be part of your common factor. Then you have x squared and you have x. And what do you remember? You take the lower power. So that will be 4x. Y is not common, so y cannot be part of your common factor. And that leaves you with, so let's do the working out here. So what do I get inside the bracket? You take each term and you divide it by your common factor. Remember, the 4x is your common factor. Okay, so you go 4x squared divided by 4x, and what does that leave you with? That leaves you with x. So that is what goes inside the bracket, x. Minus, your second term is 12xy, and you're dividing that by your common factor, which is 4x. What does that leave you with? 12 divided by 4 is 3. The x cancels out, and there's your y. And that is your answer. So remember, if you have two terms in the question, you should have two terms inside the bracket. Okay, that's the basic common factor. Let's look at a second example. As I said, this is just revision, just to refresh your memory on factorization. So we're going to quickly go through these examples. Now this example is slightly different. You have brackets. How many terms do you find in this expression? Identify the number of terms in the expression. It's quite important. So this is term 1 and that is term 2. So when you have brackets, I will suggest that you look at what's outside the bracket first. If there's anything common, you need to write that down. 3n, 2m, nothing is common. But then you look at the bracket. The bracket is actually common. So in this case, your common factor is 2x plus 5. So that is your common factor. What do you do now? So this step on the working out on what I'm doing now is optional. You don't have to do it. To those of you who are struggling with the section, I encourage this method because it helps you determine the remainder after dividing. So what am I doing here? You take each term. So in this case, the first term is 3n times 2x plus 5 divided by your common factor, which is a common bracket 2x plus 5. The 2x plus 5 cancels out, and that leaves you with 3n. And that is what you put into the second bracket, 3n minus. You take your second term, which is 2m bracket 2x plus 5, and you divide it by your common factor once again. And that leaves you with 2m, which you will put into the bracket. So what's the point of factorization? Breaking it down to one term. So let's look at this. From two terms, we have one term. From two terms, we have one term. Okay, I hope it's coming back to you. Let's look at another example. Example 3. Now, once I've used the same question, more or less the same question, but I've changed the signs inside the bracket. Now let's look at this. As it stands, there is nothing common. Remember, 2x minus 5 is not the same as 5x minus 2. But something comes to mind here. Remember the change of sign rule. I can rewrite 5x minus 2 to look like 2x minus 5. And if you remember the change of sign rule, let's quickly go over it here. The change of sign rule, if you had x minus y, and I want to make it y minus x, I'll change the order and you put the negative there. Okay, as I said again, class, this is just a revision. If you are still struggling with the content, then we need to do an online ASP and we'll explain it further. So I'm going to change 5x minus 2 to 2x minus 5 because at the moment I have no common factor. If I change that to 2x minus 5, that negative sign has to change to a positive based on this change of sign rule. You carry down the first term. We did not interfere with the first term at this point. Now, is there anything common? Yes, 2x minus 5 is common. So you will do the common factor. That's your 2x minus 5. So we're going to take the first term, 3n bracket 2x minus 5 divided by your common factor, which is 2x minus 5. That cancels out or divides into each other, and that leaves you with 3n plus, remember the change of sign rule. You've got to show this step if you want your marks. If you go straight from there to there, it is assumed that you consider these two to be the same without applying the change of sign rule. So please, if you want full marks, you've got to show the second step. That's 3n plus, your second term is 2m, bracket 2x minus 5, and you divide it by 2x minus 5, and that leaves you with 2m. That's 2m. Okay, that's example 3. As I said, all of these examples, I will scan and upload them for you so you have the worked examples. Right, let's do a few more examples, other types of factorization that pops up that you have learned. As I said again, this is revision. So I'm just briefing you with an easy type and then moving on to a slightly more difficult example. So m squared minus 9, golden rule for factorization is always look for a common factor. There's nothing common, then you look at the other options. In this case, what comes to mind here? Difference of two squares. Difference of two squares. That means you're going to open up your brackets, and if you think about it, technically you're finding the square root of each term. And if you remember, you open up a plus and minus. The square root of m squared is m. The square root of 9 is 3. That was an easy peasy question. Let's move on to the next one. For some reason, when learners see fractions, they just panic. Same method. This is difference of two squares. In order for you to identify if the fraction is a perfect square, the numerator must be a perfect square as well as the denominator. You can't factorize it using dots if both the numerator and denominator are not perfect squares. Please remember that. So m squared, 16 is a perfect square, 25 is a perfect square. So you can apply dots here. Once you identify that it is dots, you open your brackets and then you do the method of square rooting each term. So m squared, that will be m and m. How do you factorize or find the square root of a fraction? You find the square root of 16, which is 4. You find the square root of 25, which is 5. And then you put in the 4 over 5 there. That's your answer. Let's move to another example with dots. Now, we have something different here, a power of 6. It's not the power of 2. Is the power of 6 a perfect square? Yes. 6 as an integer is not a perfect square, but 6 as a power is a perfect square. Remember, all even powers are perfect squares. 6 is an even number, so it is a perfect square. How do you find the square root of an even power? To find the square root of an even power, you divide by 2 to find the square root of an even power. Divide by 2. So let's do this. Because it's an even power, difference, that's a perfect square, dots can be used here. So you open your two brackets, plus, minus, the square root of m6, so let's put that there, is equal to, you're taking the power and you're dividing it by 2, because this means 2, and that gives you m to the power 3. So you put m3, m3. And if you think about it, m3 times m3 is equal to m6. The square root of 4 is 2. Can I go further? No. That's where that answer stops. Okay, this is important, so please remember all even powers are perfect squares. Okay, grade 9s. Let's move to the last few examples before I give you an exercise to try out. Okay, what is this? 3 terms. What comes to mind? Trinomials. A lot of you had problems with this when you factorized it, but let's go over it quickly. When all the terms are positive, remember, both factors will be positive. This is the reverse of the FOIL method. So what do you do here? Let's go over the steps. You take the first term and you take the last term. All the terms are positive, so both factors are going to be plus. So you've got to find factors of 6 when added together will give you 5. And that's obvious, it's going to be 2 and 3. So x plus 2, x plus 3. Right, so remember 2 times 3 is 6, 2 plus 3 is 5. And you need to get the middle term. That's how you lay out your factors. Now this question, I'm using the same terms, but I've changed the sign. Very importantly, if your middle term is negative and your last term is positive, you will have 2 negative numbers or factors, because a negative times a negative has to give you a positive. And if you look at this, it's very similar to the first question, example 7 for trinomials. You find your factors of x squared, which is x and x. Now you got plus 6 of your factors are, you need to find the factors of positive 6. However, you can't use positive 2 and positive 3, because when you add positive 2 and positive 3, you will get positive 5. I need negative 5. So in order to get a positive when multiplying and a negative when adding, you've got to use 2 negative factors. A negative times a negative is a positive, but a negative plus a negative is a negative. Okay? So remember, when your last term is positive and your middle term is negative, both your factors will be negative. Now let's take a look. I'm just playing around with signs for different examples, just to show you how the factors change in terms of the sign. Now this is now a positive 5 but a negative 6. So remember I told you this is the reverse of the FOIL method. So in order for me to get a negative 6 here, one term has to be positive and one term has to be negative. Because a positive times a negative will give me that negative. Remember for FOIL, to get this trinomial, the third term of the trinomial, you multiply your last terms of each binomial. So a positive times a negative will give me that negative. So let's do the steps. You've got x squared and you've got negative 6. So we're going to put x and x. Now, factors of 6, that will give you negative 6. You can go negative 2, positive 3. You can go positive 2, negative 3. But what do I need at the end? You've got to look at that. You need a positive 5. If I add 3 and 2, negative 3 and positive 2, I'm not going to get 5. I'm going to get negative 1. If I go positive 3, negative 2, I'm going to get positive 1. So it's not going to work. So 3 and 2 won't be the factors here. So the next set of factors would be 6 and 1. 6 times 1 is 6, and 6 minus 1 is 5, and that's what we need. Now we need to decide where are we going to place the signs. One has to be positive and one has to be negative. Because you need a positive 5, you put the positive next to the larger factor and the negative goes there. 6 times negative 1 will give me the negative 6. 6 minus 1 will give me the positive 5. So it'll be positive 6 minus 1. Okay? Now let's look at this question. I've changed it around to leave the negative 5x and negative 6. So can you see you got a negative 5 and a negative 6. What happens? As long as the last term is negative, you will still need a positive and a negative. The only difference now is that your factors will change in terms of the sign. So let's look at it. Again, you can't use 3 and 2 because I've got to subtract. And I need a negative 5. So 6 and 1 would be the ideal values to use. If I used positive 6, I'm going to get a positive 5. What do I need here? I need a negative 5. So you put the negative sign to the 6. Because you need negative 6 plus 1 will give me negative 5. Negative 6 times 1 will give me negative 6. So that's plus 1, that's negative 6. So look at example 9 and example 10. If you compare the two, you're just changing the sign. You can always check by applying the FOIL method. Right, I think that's enough of me talking, grade 9s. We are going to break, and I have an exercise uploaded for you. I'll just show you what it looks like. So there are 8 questions indicated on this worksheet. It's just basic examples of what I revised right now. I haven't done the advanced examples. The next part of the video would be the advanced examples. So what I would like you to do now is to stop the recording or stop listening to this video, and then I would like you to attempt the 8 questions. You can show all the working out here, or you could copy down the question and do it in your workbook. It's up to you. Tomorrow I will have the answers to this exercise uploaded, because I don't want you to look at the answers before trying out the question. And then if there are any questions relating to this exercise, we will do it as an ASP online, or again you can email your question to me and I will help you with it if you don't understand my solution. I will show all the steps and put notes wherever necessary to help you with the working out, so you can mark your work and do your corrections at the same time. Okay, so let's get on to this exercise. Thanks, grade 9s. We'll see you later.